All right, so you guys, first of all, before we do the test, you still have to know how to just compare distributions and how to write proportions to make some sort of comparison between the relationships. So, angry people and heart disease. Uh, a study followed a random sample of 8,474 people with normal blood pressure for about 4 years. So, normal blood pressure. All the individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale Test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease, CHD. This includes people who had heart attacks and those who needed medical treatment for heart disease. Here's a two-way table that summarizes the data. So they are categorized by traits. So they either have low anger, moderate anger, or high anger. All right. And then what happened? Did they end up with heart problems or no heart problems? All right. So, and is there like a correlation between those? So, first of all, do you guys think this is an observational study or an experiment? Observational study or experiment, you guys?
Observational study.
Yeah, so for an experiment, you have to impose a treatment. We didn't make anybody angry or not angry by giving them a drug or something, so we just tested what they already are. All right, so we sampled them. All right, so Jake. All right, make a well-labeled bar graph that compares your CHD rates for the different anger levels and describe what you see. So first of all, in this setting, you guys, anger level is the explanatory variable. Okay, so we're classifying them by that. And then the output, the response variable, is whether or not they get heart disease. So we want to compare the percents of people who did not get heart disease in each of the three categories. So we have our low anger, and we want to find if they got a heart problem or if they don't have a heart problem. So go back up and look at your low anger when you do these. We're looking at this column. So how many out of our low anger people ended up with a heart disease problem and how many did not, right? So that's how they separated out the proportions. So out of our low anger, 1.7% ended up with a heart problem and 98 did not end up with a heart problem, right? So then we go to moderate anger, and so when you're doing your proportions, we're doing 110 over 4731. So this many people ended up with a heart condition, this many did not, and so we have our two proportions. So moderate anger people did pretty well right there. Most ended up without a heart problem. And then we have our special high anger people. See how they were worked out. So 27 out of 653, 4%, and then 95% without. So overall, people did well. And then you got to be able to make a graph. How come they only graphed the heart disease, the people who ended up with a heart disease problem? Like, why didn't they graph both? Do we really need to know this and this? What should these always add to? 1, right? So all we really needed to look at was whether or not they got a heart disease problem. A lot of times, you guys, the bar graphs are side by side, right? And you compare them side by side. But this one, we really only need the 1 since they add to 1 anyways. So we've got the low anger people, the moderate, and the high anger people. So it does appear that if you are a high anger person, you're going to maybe have some more heart disease problems, right? All right, let's go through the whole entire test. They broke this up into pieces, but I decided you guys can handle it as one big test since it's basically the same as yesterday. All right, you're welcome. So we've got our lovely table. Now, if they don't give you all the totals, remember you need to find all the totals, which they did in the last page. But remember, if they don't, go ahead and add your rows and add your columns and add your total. And then do the data provide convincing evidence of an association between anger level and heart disease? So by the way, how do I know I'm doing a chi-square test for independence? Because that is the main thing we need to figure out, right? Are we doing homogeneity or are we doing independence? Right, it's one sample of people. So had we taken separate samples of high anger, like 300 high angers and 300 medium angers, right? then we would do homogeneity. But if you're taking one sample and then splitting them up into groups based on your data, all right, it's a test for independence. So when you do your null and alternate hypothesis, who thinks they can come up with a null hypothesis in this? What do you think, Jake? Yep. Yep. There is no association between anger level and heart disease status in the population of people with normal blood pressure. So it is important to say what population you're referring to, right? Are we referring to all teenagers? Are we referring to, so in this one it's just people with normal blood pressure. All right, and then of course the alternate is that there is an association, and the rest of that's the same, right? Okay, and then we do need to say our significance level. So significance level alpha is 5%. Another way of writing these, since this is a test of independent, you can say something like anger and heart disease status are independent, all right, for people with normal blood pressure, or they are not independent, okay? So if they're independent, there's no association between them. That's another way to write it. I kind of think this way is easier. All right, and then of course the chi-square test for independence. This is the only thing that's really different from yesterday, is just stating the name of the test. Again, it's because we took one sample. All right, do we have a random sample? By the way, do we need random independent samples? No, it's only one sample, so you just have to say a random sample. All right. And then we've got our 8,474 people is less than 10% of people with normal blood pressure. Okay, so your 10% condition. And then, of course, we have our large counts, right? So for large counts, remember we do our row total times our column total divided by our total, and that gives us this one, right? So you have to do it how many times for this one? 6 times. Or we can plug it into our calculator, right? But you do need to know both ways, because I'm sure the multiple choice will have some question where you have to know row total, column total, total, all right? But let's go ahead and plug this one in so we can do the rest of it anyways. So you guys go ahead and go to your calculators, and in case you were gone yesterday, you can learn how to do this. Go to on your calculator screen, and the first thing you type in is a word to name your matrix. I'm going to just do like anger, I don't know, doesn't really matter, it's just so you remember what you're talking about, right? Occasionally. Then you guys, this is the special button that you want to push. It's got a little colon equal sign. You do control and that lovely thing right there. And then press that same button but without control to get the matrix. And we need a certain number of rows and columns. What is this one? It is 2 by 3. There's 2 rows and 3 columns. And then we have to enter it in. So it's 53. Press tab to go like between them. 110, 27, 30, 57, 46, 21, 606. All right, never enter the totals. You just enter the data. Okay, and then you just press enter and it stores it as that matrix. Oh, you press that same button but without. So maybe go to that guy right there. So now you go to menu where we find all of our stats tests. So menu, and then statistics, and then stat test, and it's another two-way test, just like yesterday. It's the same as homogeneity and independence. It's a two-way table. So I'm going to put in the matrix that I just entered, which I called anger, whatever you called, all right? All right, so we don't need any of this yet. We're going to come back to this because we will need this on the do part, right? But once you put it in, go to bars, this button here, bars. Okay, and then you want the expected matrix, and you also are going to use component matrix later, but we'll do expected matrix first because I'm trying to get the expected counts. And again, it finds those by row total times column total divided by total. So we have to write all those lovely numbers down, right? And we have to say they're all greater than 5. So for our large counts, we've got 106. By the way, you have to do decimals. Remember that, right? If you don't do decimals, you will lose points on the AP test because they want you to know that expected values can be decimals. 4624.9, 618.8, whatever that is. All right, all greater than 5. That's the magic number for all the chi-square. All right, and then we go to the do part, which is all on your calculator. I'm fine with you doing, except I do want to see the very first step for the chi-square test statistic. So, do you guys remember it? What is it? Observed. Good. Good. Over expected. All right, plus dot, dot, dot. All right, equals. So what did our calculator tell us? The p-value, or not the p-value, the test statistic was. I can't go up. Someone tell me what it is. Thank you. 16.77? Yeah, 0. Thanks. All right, and then the p-value is 3.228, right?
Times 10 to the negative 4.
That is good to know. Always pay attention to that because that makes a big difference. And then degrees of freedom is 2. By the way, degrees of freedom, the way you find it, just because it might ask you on the multiple choice test.
Number of rows minus 1.
Number of rows minus 1 times number of columns minus 1. How many rows did we have? Yeah, 3 and 2, so that would be 1 times 2. Okay, cool. All right, so we can make our conclusion now because we have a really small p-value. We will reject the null. We have convincing evidence of an association between anger level and heart disease status in the population of people with normal blood pressure. Because we got a significant result, what should we do? A follow-up analysis. So on your calculator, it will give you the components, which is really nice. So if you go to VARS again, VARS, the component matrix, and press enter, the one with the biggest number made the biggest difference. And you want to figure out which one that is. So go back to your table. And that was in this spot right here, right?
Yes.
Okay.
I thought it was one below.
So those people made the biggest difference, those high anger people with heart disease problems. All right. All right, so the follow-up analysis tells us which one made the biggest difference, which you guys can do. So can we conclude that proneness to anger causes heart disease? So when can we conclude cause and effect? Random assignment of treatments. Did we do that? No. No, we just had them take a survey, right? And then we went ahead and put them in groups. So the people already had a condition. So, nope, the anger heart disease study is an observational study, not an experiment, so we cannot conclude cause and effect. It isn't surprising that some other variables are confounded with anger level. All right, there could be confounding. For example, people prone to anger are more likely than others to be men who drink and smoke. That's what the book said, all right? We don't know whether the increased heart rate among those with higher angle levels in the study due to their anger, perhaps maybe they're drinking and smoking, or maybe even gender. Sorry, boys. All right. I know. Yeah, Abby.
I'm just wondering, why do we do that whole test if we can't conclude anything?
I mean, there's still.
It's correlational data. So
Yeah. Yeah, it still provides. So how to tell the difference between the tests for homogeneity and independence. So chi-square test for homogeneity tests whether the distribution of a categorical variable is the same for each of several populations or treatments. So you guys notice the word distribution. When you're doing the chi-square test for homogeneity, you might want to use the distributions are the same versus not the same. All right? And then when we're doing independence, a lot of times they're using association. So they're either associated or they're not associated. But the biggest difference, of course, that we talked about at the beginning is homogeneity is when you have 2 or more independent random samples. All right, 2 or more. So I got 100 boys that I'm sampling, and I got 100 girls that I'm sampling. So I start out with 2 or more separate samples. All right, and when we're doing independence, it is a single random sample. and then we classify them out, all right? That's how you can tell the difference. So on your homework, of course, don't forget to actually state all the numbers for large counts. And even if the book doesn't, make sure that you do it.